Okay, guys, let's talk about the final homework. This is a homework about a vertical merger where we've got two companies, a wholesaler and a retailer, and the wholesaler can buy shoes for $30 a pair. The retailer sells them, but the retailer has its own costs associated with sales of $10 per shoe, and that is sort of like an average. Okay, so that would be like things like advertising, maintaining the store, hiring a sales force, etc. And the final demand from consumers is 100 minus P, where P is the price they pay for shoes. So first we're going to assume that they act independently, and then we're going to assume that they merge, and we're going to sort of see how that affects consumers, but also the firm. So question 1, derive the profit maximizing price set by the retailing company R conditional on a price W charged by the wholesaler. So the profit of the retailer is, we've got a price of, I think it was 100 minus P, or sorry, that's the quantity. Yeah. So they can charge whatever price they want, and their cost is this wholesale cost minus another $10 that they have to do for their own costs. And if they charge a price P, demand is 100 minus P. So we take the first order condition with respect to our choice variable, which is our price. Derivative of this is 1, so we get 100 minus P. Derivative of this term is negative 1, so we have minus P plus W plus 10, because we have a negative 1 times these three terms. That's all equal to 0. And we end up with 100 plus 10, so that's 110, minus 2P plus W equals 0. And the price that they should charge, if we add 2P to both sides, is, and then divide by 2, we get 110 minus W, or plus W over 2 is the price they should charge, or 55 plus W over 2. Okay. Notice that the price they should charge is conditional on W. Okay? That's the profit maximizing price done. Use your answer in question 1 to write the profit function for company W. Find the profit maximizing price W set by company W. All right, so what I would do here is I would think like, how many shoes are going to be sold at this price? So at this price, the number of shoes is this, and this is going to be, instead of P, we can write 55 minus W over 2. And this is 45 minus W over 2. So that's how many shoes are going to get sold if we choose a price W, because we can imagine, we know how it's going to get passed on to the consumers in the retail price, and then we know how they're going to respond. So that's how many units we're going to buy or sell. So my profit as a wholesaler is the number of the price minus my costs of 30 times the number of units I'm going to sell the retailer. And the retailer is going to order exactly as many as the consumers want. And so this is my demand function. And if I take the derivative with respect to W, which is my choice, I get this. Derivative of that is 1, so 45 minus W over 2. The derivative of the second term is negative 1/2, so we get minus W over 2 plus W plus 1/2 of 30, which is 15. So that tells us this is all equal to 0, and we end up with 65 equals W. So the wholesale price that we're going to sell is 65. Pretty high. No, not 65. 45 plus 15 is 60. That's math. All right, so that's the profit maximizing price this guy's going to charge. Calculate the quantity of shoes eventually sold to consumers. Calculate the profits of each firm and the joint profits of both firms together. So we've got W equal to 60. Price is equal to 55. Let's see what it was. 55 plus W over 2. W is 60, so 55 plus 60 over 2 is equal to 85. Quantity sold is 100 minus P, or 15. And this is all the info we need to figure out everybody's profits. So the profit of the retailer is 85 minus costs of 60 for the wholesale price, minus another cost 10 for sale costs, times 15 units sold. And this is 85 minus 70, so that's 15 squared, which I think is 225, but I'm going to double check. Indeed, this is 225. And then the wholesaler earns 60 on each unit sold. He has costs of 30, and there's 15 units sold. So this is 30 times 15, or 450. And then their joint profits, if we add everybody together, are 450 plus 225, or 675. Now assume that they merge to form a new company Z. So what's the profit function of this vertically integrated function? What's the price, quantity, and profit? So for firm Z, they got to choose their price WP, but instead of a wholesale price, since they have direct access now to the imported shoes at the same marginal cost, 30, that's their cost. Then they have another 10 to sell them. And then they have this demand function 100 minus P. So this is equal to P minus 40 times 100 minus P. The derivative with respect to P is 100 minus P plus 40. And we end up with 140 equals 2P, or the price is equal to 70. If the price is 70, the quantity sold is 30, and the profit of company Z is 70 minus 30 minus 10 times 30 units sold. This is 70 minus 40, or 30. This is 30 squared, or 900. So notice, does the merger increase or decrease total industry profit? It increases. We go from 675 to 900 when these guys merge. But the really nice thing is that consumers benefit because the price falls from 85 to 70. So that's great. You know, that shows basically the extra inefficiency when you have two monopolies selling to each other. They have these like sky high prices because they each are trying to sort of, not steal profit, but mark up each step of the ladder. Merging on them all, we take out all that incentive to mark up all along the way, and we go to a lower price. Notice, however, though, that if we could get competition in this market, we could still drive the price all the way down from 70 to 40. That's the actual marginal cost. But that's a problem for another day. Okay, so that's the last homework. I'll see you guys all soon, hopefully, unless you can't make it to the review session.